Dead? Okay. Any issue, guys?
Can you hear me? Cool, perfect.
Awesome. Done, right? Are we ready to start? Streaming? Streaming up there? Done.
Okay, cool. Okay. Maybe you can help them with the headphone. Yeah. Okay, cool. Hey, hello everyone. This is Aniket from Remix Project Ethereum Foundation, and welcome to ETHIndia. Okay, so everybody who has worked on this smart contract development ever has definitely came across this Remix ID, and mostly people use this Remix ID for Solidity related development. And here we are going to talk about that how you can even use the scripts within the Remix ID itself. So if you have a script which is like even a JS or TypeScript file, you can run that in the Remix itself. So if you will create any workspace using the predefined workspace templates on the Remix ID, you will see some scripts out there already given. So those scripts can be run within the Remix ID. How can you run them? Basically, you can right click on that particular file that you want to run, and there is this option run. You can just click on that, and then that script will be running. And if there are any logs, those will be coming in the Remix terminal. There is another way to run the script if you want to do it a bit quick. So you can just open it into the editor, and on the left top there is this green play button which you can just quickly press, and your script will be running. Moreover, if you are a keyboard user, like you doing things quick using the keyboard, so you can use our keyboard shortcut for that. That is Control Shift S. Okay, so that is the thing that you can use you can run the script within the remix. Now we will see the use cases of it, that how it can be helpful during the hackathons, during the quick development process. So what remix provides basically, you can integrate one particular script with your smart contract. How you can do that? You can use this natspec tag, which is custom defined. This natspec tag is shown here, custom dev run script, and then you can give the path of your script. Moreover, you can go to your Solidity compiler plugin that you have been using for a long time, and then there is this new button which says compile and run script. So you can just click on that button, or just can use that particular keyboard shortcut, that is Control Shift S. And as soon as you will press that button, so that script will be running. For example, I'm just showing you one particular script. What it is doing, it is just having one particular console log, and then I can go to my contract file, Solidity file, and on the top of the file in the natspec, I can add it like this. I can add this particular tag, add the custom dev run script, and then the file path. Moreover, you can go to Solidity compiler plugin and can run this compile and run script button. And if there is a successful compilation of that particular contract, only then it will be running that integrated script. So logs from those scripts will be displaying in this Remix terminal. So you can see that the log that we defined in this file, the compilation successful log, it is visible in the terminal here. Another use case can be with the deployment. So if you will create any workspace using Remix workspace templates, there are some predefined deployment files using different libraries. You can use the ETHJS library for that, or Web3.js library for that. So similarly, you can integrate that particular deployment script with your contract. So as soon as your contract is successfully compiled, it will be just deploying that contract. So that can be very helpful when you are just making changes in your contract and you just want to quickly deploy it. So it will be just doing the compilation and deployment all together, and you will be seeing your logs and address and other things in the Remix terminal. You can extend this script to interact with the methods also. Okay, so if you guys are aware that the Remix supports the unit tests written using Mocha and Chai. So these tests can be put into a TypeScript or JavaScript file, and then they can be run within the Remix IDE itself. So if you will create a basic Remix basic workspace, you will get this storage.test.js file, which is basically containing some initial level unit tests. You can extend this file to put your logic there. And then what you can do, you can just integrate this test running with the contract also in the same manner. So what you will be doing, you will be making the changes. If your tests are like failing, your unit tests are failing, you can make the changes in the contract, and then you can just click on this compile and run script, or just click Control Shift S, and it will be running those unit tests soon after your contract compilation. And your result, the result of these unit tests will be displayed in this Remix terminal. It will be showing the summary also, that how many tests are passed and how many tests are failed. Okay, that was the unit test part. Coming to contract verification is very much integral part of Solidity development. If you are like going to deploy your application on mainnets, then contract verification becomes essential. So what you can do, you can verify your contract on EtherScan using the scripts on Remix. These scripts are kind of pre-written, so you can get them by clicking on this hamburger icon near to this workspaces label, and you will see this option add EtherScan scripts. As soon as you will click on it, it will just add some particular scripts in your current workspace. What are these scripts about? So there is one particular script which is containing the logic to verify the contract on EtherScan. So if you have ever verified the contract on EtherScan, so whenever we do it, we just get one particular GUID, and using that GUID we can track the status of it. So there is this second script that is helping in getting that particular status of that particular GUID. What we can do, we can prepare one third script as per our needs, and we can just import those scripts as I have done in this file. So you can import those EtherScan scripts, and then you can give the desired values, and yeah, your EtherScan API key will be needed because it internally will hit the EtherScan APIs. So you can provide all the values required, and then you can just run this script. The result from this script will be coming on the Remix terminal. So you can see the result. We have received the receipt, and then we have used the GUID from the receipt to check the status of that particular contract verification. Okay, so you all have been aware that GKP or Zero Knowledge Proof have been in trend these days. So what Remix supports in the field of GKP? Recently we have, okay, so first a small knowledge about this Zero Knowledge Proof. So what we do in Zero Knowledge Proof, we basically prove that this information is right without revealing that particular information. And this is creating lots of use cases. So Remix supports this Circum framework. So basically, Circum allows you to write your own arithmetic circuits for these zero knowledge proofs. There is this circuit programming language which you can use to write your own logic. And then basically when you will compile it, there is a definite compiler for this. When you will compile, you will get a generated Solidity code also that you can use for the Solidity verification purpose. So we have some predefined workspace templates for that. You can just go to create workspace, and on the bottom you will see these three new workspace templates. For now, I'm just going to have show this hash checker template. When you will create this hash checker template, what it is doing, it is basically verifying the hash of 4 values without revealing those values. So you will get this file that is having this extension .circom. So we call it circuit in the terminology of this circum compiler, and then there are some scripts to run the setup and then to run the verification of the zero knowledge proof. To compile these circuits, you will need this GKP compiler. You can activate it from the plugin manager, or whenever you will create a new Circum GKP template, it will be activated automatically. So you can just compile that contract, and then there will be related artifacts in your workspace. You can then run those scripts for the setting up this zero knowledge proof process. It basically use this snark JS library, and yeah, if you will create this workspace, it's README file containing all the details. So you can just go through that, and it will be giving more information on that. Okay, so if these days we did not talk about the AI, so that will be difficult. I think so. What we have recently introduced in our release last week, we have introduced this Solidity Copilot. Some of you can be aware about its name. So what you do when you just type some code in Solidity, it just shows you some code suggestion as soon as you type, and it is an opt-in feature, so you can just enable that from the settings section of RemixD. And we have released it into the alpha manner, so we will need your feedback on that. I can just show you that how you can activate it. So you can just go to settings section and check this particular box, load and activate Copilot. It will take some time. Just wait for it as of now. Do not close this particular dialog. It will take 4 or 5 minutes to download that particular AI model, and then you will be just using it. So if you are looking to just write an ERC20 contract, as soon as you will type like contract ERC20, it will show you some of the suggestions, and you can press tab to adopt those suggestions, and then it will show you the further things. So I have some screenshots here because it is difficult to like demo it on this low Wi-Fi. So you can see that as soon as you will type, it will show you some suggestions. As soon as you will press tab to adopt those changes, it will show you the next thing. Another thing is that like if you are working on an owner contract and you want some custom function, what you can do, you can use triple slashes for that, and you can just ask anything. I mean, ask any code. You can just say write a function to change owner, and you can just press enter, and it will show you that particular code. If you are okay with that, you can just press tab, and that will be added in your code file. And further, you can ask for another method like read owner, and it will be like coming further on this on your code file. It can work slow a bit because it is still in alpha phase, but it is there. Okay, moreover, what we can do, I mean, when we do the development nowadays, I think it's, beyond the Stack Overflow, we just go to ask thing to ChatGPT. So what you can do, you can ask things to ChatGPT directly from the Remix IDE. If you are getting any compilation error in your contract, you can just click on this Ask GPT button, and it will be getting the answer for you. So if you will see these green boxes, it is just also showing you that how you can fix your code, and that is happening within the Remix ID itself. So that can be quick when you are like doing things during the hackathon. If you are looking to ask anything custom, you can use Remix Terminal for that. You just need to write GPT and your question there. So for example, if I say, okay, GPT, where is this ETHIndia? It will just show you the answer in that Remix terminal itself. And that is it. Thanks for being here. And for more queries, you can join this. You can scan this QR code to join Remix Discord, and yeah, we can talk there, and we can have some queries here also. Thank you, everyone. Sorry?
Do you have bounties over it?
No, we have bounties from Ethereum Foundation, but not exactly from the remix. We have different project from Ethereum Foundation. Yeah, yeah. Thank you.
Yeah, yeah. Ethernet, I will. Yeah. No, Wi-Fi not. Okay. Yes, I think so. Just let me check. So, yeah, good. It's fine. Yeah, it's sorted. Thanks. So, yeah, yeah. All right. Hey everyone, this is Harsh. All good. Hey everyone, this is Harsh from Push Protocol, project lead and founder. Today we are going to talk about how you can build Web3 messaging and notification apps, or how you can build your dApps using Web3 messaging and notification. But why is it important? Well, just think about it. What's the first thing that you do in the morning? You take your phone out and you see all the notification from all the Web2 apps that you have, whether it's email, whether it's Discord, whether it's Twitter, whether it's any gaming. All of them, they send you notification telling you something important for you has occurred and what you want to do. And that is how Web2 operates, and that is how Web2 scales up in the UX. But yeah, when you come to Web3, notifications was not there. And that was why Push was created to enable Web3 apps and enable Web3 contracts to send notification out to you along with other form of communication like chat and video and so on. So how do we do it? Well, we do it by making sure that push becomes this decentralized communication middleware using which any protocol can send any communication, whether on chain or off chain, including notifications that are then tied to your wallet address. And because push is an open and secure network, now any crypto wallet such as MetaMask can tap into this network and can show these notifications out to you. Why push Web3 notifications? Well, just think about it. Your protocol is a smart contract or it's a Web3 backend, and your usernames are wallet addresses. Therefore, it makes so much sense to send a re engagement notice to them when, let's say, someone's ENS expires or a DeFi loan is about to be liquidated, and so much more. And that's why push notifications. We are very happy to announce that from when we started notification to now, we have become the market leaders in that. And because of that, we spoke to a lot of partners, and then they said that apart from just sending notification out, they wanted to know the preference for the users. And that's why we have notification settings, and we'll have the workshop to look into it. I'll just briefly touch upon the next step in push notification, which is push chat. Basically, notifications enables re-engagement for your app, and chat enables socializing in your app, or at the worst case scenario, making sure that you have a support chat wherein the wallet address that's interacting with your protocol can have a direct line of connection in case something goes wrong. So push chat, it basically enables a lot of cool things. Some of them are group chat, including token gated chat. That is something that is not done in Web3 or not done in any messaging platform. Other things is, of course, support chat. You can also use it to negotiate NFTs and so much more. Again, gated group chat is something that we are going to go into. Gated group chat is really interesting because what it can do is it allows you to create on your front end a way for wallets to come and interact based on gated condition, such as if they have 30 Matic or if they have, let's say, 1 ETH, only then they can join your group. If they have 10 ETH or 40 POAPs, only then they can talk. This is extended to push spaces as well, which is kind of like Twitter spaces where you can token gate the entire conversation. But for this demo, we are just going to stick with notification and chat. Just a little about how Push has terraformed the entire Web3 from then to now, which is 2020 to now. We have sent over 55 million notification to over 150,000 subscribers and have 650 plus integrations, including the likes of Uniswap, Polygon, Unstoppable, Gitcoin, Decentraland, and so much more. One more thing, guys, like we started from ETH Global 2020 as a hacker. So we are really looking forward for some of the really neat and cool creative innovations that you guys will do today. All right, so on to the demo. Let me just go and start the demo with a dApp. So let's just go to staging.push.org. You can go to app.push.org for mainnet apps. But because this is a staging, we'll go over here. We'll sign in. And the very first thing that you see for notifications are channels. So what are channels? Well, channels are your protocol that have activated themselves on our protocol. Why do we need channels? Well, because this is a Web3 interoperable network, you will have many protocols sending notifications out, and we wanted to make sure that the user has this in as anti-spam way as possible. So when your protocol creates a channel, after that, if a user logs in to our dApp or to your front end, because this is happening on the protocol, they basically see this opt-in button, which essentially allows them to opt in to a channel. Once they have opted in, only then the channel can send a notification out. And once you have opted in, that's about it. You, as a user, are all ready to see the notification out. But how do you send a notification? So this wallet address, I've already created a channel. But to create a channel, all you have to do is go to push.org/docs, scroll down, go to notifications, and over here in the tutorial, you can see how to create your channel. It's very easy, takes 5 minutes, and it's a one-time process. Once done, your channel is ready. And once your channel is ready, you can send notification out. So for this demo, I also have created another user on Firefox, And what I've done is I've opted into this hackathon channel. But yeah, let me opt out and refresh and let me opt back in. Because as I said, we also have notifications. So once you have your channel, if you want to add notification settings, you just have to go to manage settings and you can do settings like range and announcement and so on. So going back, okay, hopefully it loads up. Yeah. So I have this channel, I opt in because I have these settings, I can also turn it on and off. So let's say I want my loan health notification when it's at 105, I don't want announcement. And that's it, I do opt in and I'm all good to receive notification. So how do I send it out? Manually, if I have to, I'll just go to the tab, go to send notification. You can choose what type. Broadcast is sending to every user of your channel. Targeted is sending to just one. Subset is sending uh, to a particular batch. So, and then you can type in your message. But notification doesn't have to be just title and message. It can be so much more. For example, I can also have a media URL. I already have a cat selfie over here, so I'll just put in. I'll see the preview. I can also set what notification setting I'm sending. And if I do that, then basically if the user has opted into that setting, only then the notification will go. With default, it will go to every user. So once that's done, I'll just gaslessly sign it. And that's done because it's a broadcast. We get a notification over here as well as we get a notification over here. I had sent a notification earlier, that's why you're seeing two cats. But not only that, you also get a notification on MetaMask because we have MetaMask X Push Snap. Of course, this is listening to production, so you see notification from the channel that I've opted in. And you also get a notification on the extension on Unstoppable and all the wallets that have already integrated us. So yeah, that's how easy it is to send a notification manually. But we don't want to do manually. We want to do it via API, right? So again, best way to do it, go to push.org/docs, go to notification. There are two ways by which you can play around. One is you can play around on the docs itself. So for example, we have this live editor, which has our SDK loaded in. And you can just play around with this. For example, this is fetching all the notification by using a notification.list API. And all I do is fetch notification over here, sign, and it will fetch my notifications. Same thing, I can also stream notification. This other example tells me how to stream the notification out. I can just click trigger notification over here, and it will trigger it out. So that's one way. But other cool way by which you can do it is by going to our push SDK. You can go to Playground and it will tell you how to download and how to set it up. But going to our push SDK and then going to packages and examples, and you have all the examples about all the things that you will need over here. But let's go to boilerplate for once. Let's go to code. I've already added my wallet address over here or the private key of the channel. It's doxed. But yeah, how to send it out? First thing, I'll create a user. So it's user Alice. I'll just do await. I've imported push API and constants from push protocol REST API. So push API dot initialize. I'll pass in the signer and the constant dot environment dot staging. Best way, like whenever you are doing either notification or chat, you have to initialize the user first. So best way, just do a copy and paste. Uh, so I'll just do that. One signer is there and user Alice is there. Now I just want to make sure that I know the signer address, so I'll just do this. And yeah, I'll just do yarn start. And the address is here. Okay. To now, let's say I wanted to get my subscribers. So how do I do this? I do const sub equals to await user alice, which is what we have initialized, then channel dot sorry user alice channel dot subscribers. This will fetch me all my subscriber, but I wanted to pass some option, so I want just page one. I Yes, page one is there. Limit, I want that to be 20. And I also want user settings to be delivered to me so that I know what settings have been opted in by what users and I can respond accordingly. And I'll do console.log subs. And it will take a second and you'll get all the subscriber setting. But yeah, what about if I want to send a message out? It's just as easy as again going to docs. Uh, I'll go to send notification. You can send notification via smart contract as well. You can check that out. But for this, we'll just stick to sending notification from here. So when we are doing send asterisk, that's broadcast. But this time around, I just want this to be targeted. So I'll just add one wallet address over here and I'll do channel.send. I'll pass title and body. And yeah, that's about it. You can already see the notification is delivered. So that's easy. That's as easy as it gets to get the notification set up and running. And if you want an advanced version, you can just go through the options. Very quickly, we can also touch on chat. So chat is even easier. Again, best way, go to push.org/docs, go to chat. So as I said, like the least you can do to make sure that your user experience improves is to have support chat, right? And what we have done is, while you can of course build everything out on your own because you have again initialized user and all the API calls, but what you can do is also go to UI components and it's just a one line code for UI component unless you want to themeize it. So all you need to do is import UI web and get this component added in your front end. And once you do that, you will see the chat over here and you can just chat automatically. Now over here we have passed in the wallet of our AI bot. So if I just start chatting with it should reply back very soon. So yeah, that's as easy as it gets to get the support chat going. Even for push chat is the same thing, just 2 lines of code. And I spoke about token gating, right? So let's say I wanted to create our token gated community. So one thing you can do very fast is you can go either over here and get the rules, or you can just go to chat, create a group, name the group out, and you can add all your conditions that you want, whether you want token gated NFT or custom gated. You can do that. You can gate on entry as well as conditions on if they can send a message or not. Once you are done with it, what you'll get is this chat ID. Uh, Let me just open a group out. So let me go to push.org.brb. So we have this token gated group created over here. So go to group info, you will get a chat ID. And all you have to do is pass that chat ID right in the component. So for example, over here, this is the chat ID of Marv, but now if I change it to BRB chat, it will load BRB chat. So it's as easy as that. If you want to send a message out, let's say via chat over here, all you have to do is chat.send content hello Bob. And once you do that, in the Firefox, if I sign this message out, let me load it. I'll see the message. Uh, Chats again are anti-spam, which means chat land on the request tab. You have to accept it out. You can do it from the SDK or from the front end. That's your call. But yeah, that's how easy it is to integrate push into your apps. I do have some time for questions, 2.5 minutes. So yeah, any questions? All right. So no questions again. Because I have 2 minutes, I can probably retouch on things. Go to push.org/docs. That's the best way to start. Everything that you do will start from initialize user. All the API calls are there. If you want more help, the best thing you can do is get the push SDK out, like clone the push SDK and go to packages and example. And you have all the examples, including token gated chat, including automated chat and chat stream. You can just go over there and do a yarn start, and it will basically tell you how everything is getting done. And you can go to code for each of the example, and you will have the code of how everything is done, even streaming and everything else. All right. Hope you enjoyed the presentation. Thank you, guys. Uh, if you want, just scan our Discord link or our push doc, or you can also go to our live workshop, which has everything in detail. And yeah, yeah. Aw- Awesome. Also, we have cheat sheets, which basically is a summarized form of everything. You can find our team sitting at the back wearing pink, cotton candy pink. Yeah, just take a cheat sheet out, and we are at the booth to help you guys. Happy hacking.
Do you have your hands on mic for him? Yes.
Good afternoon, everybody. I'm assuming you guys can hear me if you've got the headphones on. So we're the team from Chainlink Labs, and I'm just going to, while we set up here on the laptop.
This will be terrible.
Right. I'll use this one. That's fine. We'll use this one. Sorry about that. Yeah, so we're the team from Chainlink Labs, and we're going to present to you a couple of our big flagship products that have come out this year, which is going to be super exciting. But for you to know why you need to listen, and we'll tell you what we're going to talk about, but for you to know why we need to listen, I'm going to get Ash Goyal to tell you what's on for you guys at the hackathon today, and then Solange will take over for the first bit of the presentation.
So, welcome everyone. Can you put your presentation is ready?
It's connected.
Yes. So with this, we are here to talk about functions and about chaining CCIP, but I know that you'd like to know about the prices. So Ash is here to talk with you about the prices.
Yeah, thank you so much, Sol, for introducing me. I hope you all are doing great and super excited to build on Chainlink, and all of you are here for building some cool stuff. So the most interesting part, I believe it's something that we are going to discuss right now. That's about the bounties, right? So if you already have worked upon Chainlink or you know about different Chainlink protocols, so we have something known as Chainlink CCIP. So if you're building something or integrating your project somehow on CCIP, so there's a special bounty for $1,000 that you will be getting. $1,000 for two people would be selected, $1,000 each. Same is the case with Chainlink functions. I believe for CCIP and Chainlink functions, Zubin and Sol will be taking you through what it actually means. But yeah, for Chainlink functions as well, we'll be having two prices. $1,000 each. And if you're using any Chainlink functions, right, you're building something on Chainlink, there is one winner who will be using some other Chainlink services. Thank you so much. I'll hand it over to Sol for taking you through CCIP.
So another important point for you, this is the QR code of the presentation. So read this QR code now, and then everything that we are showing to you later, you don't worry about it because you can have everything in your own computer. So I can give you 1 more minute to this. And one point related to the bounties, especially when we are using the other chaining services that are so cool. I love it. But you must be sure that you are doing some on-chain transaction. For example, if you use data feed, but the data feed is only in the front end, doesn't matter to us. So if you're using data feed, but you are saving that information inside the smart contract, yes, this is good for us. So the transaction must be on-chain to use Chainlink. Okay, let's go forward. So this is me. You have this. And let's go a bit forward. I'm here to talk about CCIP. So I really love CCIP because of all the cross-chain things that we can do. And I will do a demonstration for you related to a NFT emoji that it's based in the Bitcoin price. And also I'm using DataFeed to do this. So this is like almost a game because I have different NFTs. The NFT can be minted from the same chain. I build this on Mumbai, but I'm using to mint the NFT from Fuji, Avalanche Fuji, another word. So with this, we can connect the words in this way. And yes, you have the other QR code, so I will pass this so fast for you, but this is the smart contracts. And how can I do this? Let's go. So here I have 3 contracts for you, and I'd like to show a bit of this for you. So first contract is the NFT itself, and this NFT is useful for you because I'm creating an SVG file, an image directly inside my contract. So can be useful for you to understand how this is built. And also, I have here the source chain, the chain that I'm using, all the information related to the chains. And I'm updating the metadata itself. It's inside my contract. So I'm create a JSON file inside my smart contract. So this is a different way to create a smart contract and an NFT because I'm not using something like IPFS. I have everything on-chain. And okay, I have this cross-destination minter. This is a contract that you mint the NFT for me. And because of this, I'm using the CCIP receiver. If you are using CCIP, you must have in your contract a function called underscore CCIP receive. And this function, you execute any message that you receive from the source chain. On my case, this message will be like the mint command from the other chain. So this is the address of my NFT, and I'm calling the message that will be this. At the end, I have the minter, the source minter. This will be on Avalanche Fuji for now. And here you can see that I'm using the routers of Chainlink to have this part. And then I'm really using the mint on Mumbai, where I'm using the structure of Chainlink, the message, the EVM to any message. And here you can see the mint command. So I'm sending this message, this mint command to the other chain, to the other part of the world. So is this. I already deployed everything because it's like a bit impossible to do this so fast. And what I'm doing now, this is the NFT. I have some here. In fact, I have a lot. I will refresh. Let's see how many I have now. Okay. You can see over there that at the end I have 2. Both came like from Polygon. We have one more here because I will do a transaction just now. So I'm going, probably, let's see, I must be on Fuji now. Yes, I am on Fuji. I deployed everything before, like 5 minutes ago. And I am in the cross-source minter. Oh, by the way, I must pay fees. I may pay fees using the leak token, but you can use the native token as well. And I'm using the mint on Mumbai now. So let's mint in the other chain. Confirm the transaction. How can I know the status of my transaction? I will use the CCIP Explorer to do this. So let's see if my transaction is confirmed. Yes. Let's get the transaction ID, go to the Explorer, and see what's happened now. And yes, we have the search finalized. We must wait some time to have the finality of this. And then I can come back here and explain a bit more for you. Let's see how is my time now. Okay. Is this? This is the, I'd like to go over there, but I must be here. So let's try to do it this way. Like we have the search part where I have the DEP, the user over there is my search smart contract. I'm interacting with the router of Chainlink. The router is interacting with the off-chain part where we have the DONs and the validators. Zubin will talk more about the DONs later. And then this router is sending that message, that transaction to the other chain using the router in the other chain. And that router, the destination router, is sending this message to my application, my destination minter, who is interacting with my NFT, minting a new NFT. So this is a high-level architecture, and probably you are thinking about security of this. We have, in fact, more than one actor acting in this way, because we have a risk management network that is having votes as well and having a consensus to be sure that we can commit this to the other chain and don't have like a reorg in the chain and your transaction can disappear. No, this cannot happen because we are taking care of the security of this. And I think is this. Let's see if probably my transaction is not done yet. And I must wait a bit more. I'm waiting, and in this time, Zubin, you talk about functions for you. So Zubin, it's your time now.
Thanks. Thanks, Sol. So while we're waiting for CCIP to do its magic and for the actual transfer to happen of the data across the two chains, I'm going to present to you a slightly different concept, right? It's a slightly different product. So we're just going to switch while that's running in the background. So I'm here to present to you on Chainlink functions. Now, how many of you know what an AWS Lambda is or Google Cloud Function is, right? Okay, excellent. Let's start with that as a mental model, right? First, let me introduce myself, though. My name is Zubin Pratap. I'm a developer relations engineer at Chainlink, a recovering lawyer, ex-Google Suite, et cetera, et cetera. This is the best job in the world. I get to work with people like Sol. Such a pleasure, right? Now, for those of you who aren't familiar with Chainlink, and I know there are a few of you who aren't, it's basically an Oracle service. But why is that important? Because it's not so much what it does, but why it's important, right? As you know, blockchains are deterministic systems. They don't really access the external world because if they did, they wouldn't get consensus across all the nodes in the blockchain. And so what you need to interact with the rest of the world and with other data systems is you need an Oracle service that sits in the middle, like a middle layer, right? So that way you can move data on and off chain. However, you need a decentralized Oracle network to make sure you don't have a single node that's a single point of failure. And that's kind of what Chainlink offers, a decentralized Oracle network. Not that Don, but it's funny. So the decentralized Oracle network is a series of nodes that run off-chain but preserve the cryptographic guarantees that we've come to know and love from the blockchain world. So even though it's off-chain, it has the same concepts of consensus, cryptographically verifiable data being put on and off-chain. And that's what Chainlink does, right? It produces a middleware. So you get decentralization, trust minimization, scalability, truth through cryptography, and verifiability. And you also get reliability, responsiveness, and cost effectiveness because you're not doing a whole bunch of compute on-chain. You can move it off-chain without losing any of the guarantees. So there's also consensus protocol in Chainlink DONs, and that's OCR. Okay, so I'm running through all this just out of mindful for time. Now, this brings us to Chainlink functions. So going back to the AWS Lambda and Google Cloud Functions sort of metaphor in your head, if you like. We at Chainlink started to say, well, what if we could run absolutely any arbitrary code that you wrote? Any code, okay? And the execution of that code that you've supplied, let's say in JavaScript, is decentralized. So you get decentralization of the execution of that JavaScript code. And the result of that execution is cryptographically verifiable through the Chainlink consensus protocol known as OCR, right? So you combine all these things and you get Chainlink functions, right? With which you can call any API anywhere in the world run compute on it that's much more gas effective than doing it on chain, get consensus on the return result, and have that posted back to your consumer smart contract, right? The smart contract that consumes Chainlink functions. So why do we need that? Well, we believe that the new generation of Web3 apps are going to be hybrid. There's going to be a critical on-chain component, and they're going to be able to access traditional data infrastructures so that you can enrich the Web3 world with that data without losing a lot of the the benefits of decentralization and trust minimization. Right. So, big diagram. Just to tell you that that's all you need to worry about is this bit on the left. This is all you need to worry about. Just put your smart contract up, have a subscription, and invoke your Chainlink functions. Everything else is done by the Chainlink decentralized Oracle network and the technology we've produced, right? Your workflow broadly is 3 steps. Write some custom JavaScript, write your Chainlink consumer contract, right? Your functions consumer contract, into which your JavaScript, your API keys in encrypted form, all of that will go in there. Your smart contract will then contact the Oracle network, and the decentralized execution will trigger, and you get your result back in the consumer smart contract that you control, right? So in terms of how to get started, now for those of you who are going to do this in the hackathon, obviously, as you know, there are bounties for both CCIP and functions. Both Sol and I are going to be here for the next 3 days to answer any questions you have. But to get you started, take a look at the following, right? run-functions.app, right? This is a bunch of community-generated examples of Chainlink functions. Take a look at them. The basic concepts are all broken out. And obviously, you can go to the docs.chain.link where all the formal documentation is. But this is community-submitted examples, right, of people writing decentralized functions code. You can also play with it. A simulated execution environment for your JavaScript is provided in browser, where you can do a kind of pre-run, right? You can debug and you can do a dry run of your custom code in this, supply your arguments, supply your secrets, and it'll spit out the hex output and decode it for you so you can see what it would look like on-chain. And you can use the NPM toolkit, which is an NPM package that I co-wrote with a couple of my colleagues, and that abstracts away a lot of the complexity and breaks it all down into steps. And the documentation is pretty good, if I may say so myself. It's pretty thorough, but we want feedback from you. Use these 3 or 4 things, and you should be absolutely without any problem using functions. It reduces what used to take three to 4 days, spinning up your own node and all the rest of that, to about 20 minutes now work, right? And so you can connect to any API. Now, I also did a deep dive at our Chainlink hackathon, which, by the way, you can still participate in at the moment. It's going on at the moment. You can submit to both. There's no problem from our point of view. But you can also watch the deep dive of the Chainlink functions, deep dive that I did on YouTube by scanning that QR code and going and taking a look at it, right? These are some more resources. Sorry, this is Sol's. I'll give it back to Sol.
So I'm here again. You already have the presentation, but I can give you a minute to get if you was a bit late to get it. And yes, we have more resources for you in our documentation. But what about my transaction? Let's see what's happened. Yes, success. Yes, I'm so happy when this happened. Always. Let's see what's happened. Remember that yes, and this is also updated because I have a new NFT here just now. And this NFT should be one of these reds. And this is the 8, probably this is the last. Yes. Yes, the 7, the 4, probably must be so recent. Let's see if it's this. No, I didn't refresh yet, but it seems to refresh it. But by the way, let's come back here only to see how is my time. Oh, we have a lot of time. Yes. So let's see what's happened because I don't know. It's by price. Can I do by recent listed? Yes. So one of these, you'll be like the last of this. Probably this is the last. Yes, it's the 8, like it was before. And you can see that I minted this from, like Fuji was my red chain. Blue was the Sepolia and purple was the Polygon. And you can see here that I did this in the details part like 7 minutes ago. So it was here, it was now. And this you can see the price in that moment. The source was Fuji. You can see the same. Let's get, for example, one of the others to you understand this better. Like I did this yesterday. I think I started this yesterday. And if I go this, you can see that it was another price. It came from Sepolia. And yes, it was 1 day ago. So they are real. They are minted in different times. different chains. So this is really, really amazing. And to summarize this as well, the presentation a bit more. Do you need it? How good of this? Yes, I'm missing some phones over there. Let's wait a bit. Yes, we have time. And okay, yes, and we already share with you a lot of resources, but especially related to CCAP, you can go to the documentation. A lot of people ask me about the supported networks, so you can see the supported networks directly on this link as well. And you know that's a bit slow here, but you can see the test nets, especially here we are using the test nets. And here we have Sepolia, Optimism, Mumbai, Fuji, BNB, and Base for now. So this will be useful for you. And also, we only talk about the messages, but what about to transfer tokens? Because the CCAP also can transfer tokens. And yes, can be used like a bridge. We have some tokens that is managed by Chainlink, and then you can transfer this kind of tokens, or you can create your own pool managed by you, your application, and then use this pool using Chainlink CCAP only to cross the tokens. But if you are using, for example, the tokens that we are providing to you to test, here we have the link of the two kind of tokens, because we imagine I have a token in one chain. What do you do in the other chain? In the first chain, I'm burning the token, or I'm locking the token. I must do something to this token not be used in both chains in the same time. This is the point. So we have this token, burning mint, lock and mint. You can use this. In the second chain, I must have my decision as well. I'm minting the token in the second chain, in the destination chain, or I already have these tokens over there and I will unlock this token. Depends of your business, but we have some tokens for you to use to have the solution. Oh yes, okay. Oh, I talk more than I need now. This is the developer part for you. So we have all the information here, and I think we are done. So see you around. We are over there. Bye. Yes. Bye.
No, we don't. We don't. Should be fine. Yeah.
So once you're ready, they will switch.
Yeah, just is there a timer? Yeah, we got to go. You want to start?
Are we on? Yeah. Okay. Awesome. Yeah, this is a little odd because I don't get to hear a speaker feedback, but I hope it's all good. Yeah. All right. Cool. Welcome to Pauloom's hands-on workshop session. Here, the agenda is very simple. We want you to just take a quick walkthrough of the kind of things that we have opened up for the different tracks that we're sponsoring for prizes in ETHIndia. Uh, what we have is essentially two broad categories where you can start working on the Pauloom protocol. One is to join the network as a protocol node itself, which could be a little bit more on the advanced side. We'll take a look at that. But also you could use a pre-existing APIs on the data markets we have already seeded, like Uniswap and then other ZK EVM transactions, etc. So we would like to help you with that as well. So along with me, I have Akshay. I am Anumit, the co-founder. Akshay is my senior most engineer from Pauloom. So we'll take you through a quick overview. via some screen recordings as we introduce a lot of concepts. And do remember, like, these concepts make a lot more sense if you do have the documentation, like the docs.parloom.io. If you just go there, having that as a ready reference will really help you to go through these sections and expand on them. Other than that, we'll always be at the booth to answer all the queries and at the Discord, right? So Akshay, on to you, where you kind of introduce the hacker dashboard, also show them through what the protocol is kind of built off and how they can join the network as a snapshotter, right? On to you.
Thanks, Anamit. Yeah, let's just go over the hacker dashboard. Yeah. So here I'll be showing a demo. Like, this is the hacker dashboard we have built for people to build on Parloom. Although the network is open source, like, we had to open up some of our nodes, so we had to put in some API rate limits just temporarily. So in this demo, I'll be showing how to sign up, use the API keys, and all of that. So this currently uses Magic Link. So the sign up process is very easy. You just verify your email and that is it. So once you enter this, you just go back to your tab. And here you should see your profile details, your rate limits and everything. And this is your API key which you can use for, like, if you need faster rate limits or anything. And if you are a snapshotter and you need to run a snapshotter node, then you will need to register your wallet, which is as simple as just submitting this submit button here. That is it. It registers your snapshotter in our contracts as well, and that should be good enough. So once you have all this set up, you just need to refresh the page once and it will show you your wallet address, like it has successfully registered in against our smart contracts, just like this. And then you feel free to run your own node. Next, let's just go over the process of actually deploying a snapshotter node, which is relatively easy. Let me just, okay, where is this?
Yeah, all right. While you go in there, this is essentially something that we've opened up to you, the participants of ETHIndia, as a network that you can join, start running your own data sources, and you're not restricted by any consensus mechanisms. All right, Akshay, why is your browser hanging?
It's
Just
not
give
even
us a
browser.
second. Yeah, it's back.
No, it's not.
This seems to be a glitch. Hold on.
Sorry, just a second. What is this?
Shit happens. Are we back?
I don't. Ah, it's there. Maybe my screen is frozen.
The screen is possessed.
Yeah. Okay.
Let's go from here.
Let's just use this. Cool. So
All right. Please continue.
yeah. So
What are we looking at first?
yeah. So this is just an example. So we have this Parloom/deploy, which is our current deploy repo. So all you need to do is you just need to clone this repo. The instructions are right here. So any server or like even Google code space, GitHub code space should be good enough. So you just need to clone the repo. As you can see, you just clone this. Now there is this env.example file, which has these bunch of like configuration variables. So if you take a look at this, the first one is the source URL, which will be your RPC. And then the second one is the signer address, which you just registered on our hacker platform, and the signer private key. And the next bit is, this is the important bit, right? So like the snapshotter node is designed for people to swap in and out like computation modules, so you can build your own use cases really easily. All you need to do is like just set these configuration parameters, which is basically the GitHub repo link and the branch name. So you can just fork default branches just like this. So this is the, yeah, this is, I'm just forking the snapshotter computes in my own personal profile. And the same thing you will need to do for the config branch as well.
Do check out the documentation on the snapshotter architecture. It
Yeah.
shows you how it's decoupled. So essentially, we want people to start using the data first. I mean, the other market dynamics will come in later, whatever people want to decide in terms of what is, attractive in terms of contributing to snapshots. But at the moment, what we have here is no restricted, no holds barred, all configurations given to you as
Yeah.
part of what protocol you're going to participate in, what is your signer account address, which is what you have signed up for, by the way, on the dashboard, just to remind you.
And this is like you can see the config repo. This is currently my own repo, right? And yeah, that is it. So once this is done, let's move on to the next steps, which is basically running this bootstrap.sh, which basically clones all of these repos in your local folder, so that it makes it really easy to configure and run this entire setup. So let's just run this. So yeah, if you look at this just cloned pooler all of your configured snapshot or compute modules as well as the config files, and everything is ready to go. And if you just go to pooler/config, let's just see the remote, like from where it is cloned, right? Which branch it is currently on. So if you take a look at the bottom of the screen, so as you can see right now, it's using my fork branch instead of the default pooler one. Yeah, that is it. So now we have everything ready. Now the final step is you just run this entire setup using build dev sh in a screen session, and that will start up the entire snapshot node.
Let's see.
Yeah, let's just see. So you just need to run build -dev.sh, and it pulls a lot of these Docker containers, build all the like needed infrastructure and everything. It sets up everything up. Let's just speed this up a bit. So it's just building things.
So it has a bunch of moving components. We have essentially done the bootstrapping, what
Yeah.
you noticed, so you don't have to sit and tinker with the internals. It is just launching your own self-contained node on the network with its own custom data sources, which on top of you can write your own snapshot logic, right? So that's the part we'll take a look at.
Yeah. So right now the building process is almost done. So if yeah. So yeah, all layers exported. It just started everything. So yeah, so a lot of logs are there, I understand, but yeah. So if you go again to the readme file, it exactly shows you like this bit, right? This will show you the state of the system, if everything is active or not. So using just docker ps, if you just do that here, you will be able to see like what are the containers running. You'll be able to go inside the containers, access APIs, which ports are exposed. Everything is shown right here. And the final step that I want to show is how to access this core API. Core API is basically like a set of set of utilities which enable easy access to this data that the snapshot node is generating, right? So all you need to do is just if you have not configured any URL, you just tunnel to that instance, and that way you will be able to access the core API in your local machine only. So all you need to do is, if you just go to localhost :8002, yeah, it will show you the exact core APIs. Like we have a nice Swagger interface for you to see as well. So like, and you will be able to access any core API very easily. Next, Anomit will explain the protocol state and the details. What are the project ideas, tracks, and what to build on? Yeah, Anomit.
All right. So first of all, your glitchy thing, I have to figure out how to move to the next. Yeah. All right. So I know that was quite a bit of concepts, right? And also because of lack of feedback, I'm not sure where you might be having a little bit of doubts and clarifications you require. But yeah, in short, what he showed you was like a quick introduction to what the protocol is like and how do you join it. Let me kind of ease a little bit further into it by using one of our existing APIs. So like I said, you could either join the network or you could use you could either join the network or you could use one of our pre-existing APIs. So this is the one example I'll show you. It's from our docs, and we have had this recorded so that we knew this kind of glitches come up, so didn't want to run into that. So let me maximize this. Okay. Yeah, this should be good. All right. I'd love to have seen there. All right. So what you see over here is like some of the project ideas we hope people would build on. So one of the things we have is already implemented as a Uniswap V2 dashboard, but how can you build further on top of it is it might help you to kind of get a quicker look at what's the data market like, what do we mean by data market, and what are these different smart contracts. Essentially, this is what you want to build, right? What smart contracts you want to serve data on top of. What is your definite use case? So this is exploring the Unisoft V2 dashboard. We have broken down in detail. This is the data sources. Akshay has linked them from the ideas Notion document page, so definitely go through that. That's an exhaustive list. A project ID is nothing but think of it like a stream of data coming for per contract that is noted in the projects list over there, right? So once you're kind of clear on that aspect, that what a project ID refers to, it's like a stream of data source. That is where you can really start playing around with further use cases, like more flexible ones, where we are kind of serving something for a Quest dashboard on this partner called Merkle. Merkle, like with a C, not K. So over there, they follow the same project IDs. They capture our data feeds. Then they use that as a user completing different quests, like asset bridging, then supplying liquidity to certain dexes, and they are going through certain social quests, right? So that's like an exhaustive list of data sources. But here is where the things get interesting. You start seeing things like aggregates, right? What do they mean? So aggregates is essentially like, if you think of like data composability, you can sum together a lot of data sets and it becomes an aggregate. We have some Pooler API docs for you to start playing around with the same project IDs that I noted over there. Epoch is essentially what determines all the data sets on Parloom protocol, right? And Epoch is comprised of a certain begin to end chain height range, and you can take any of these project IDs and start querying further information relative to certain epochs right from that Pooler API doc. So I'm just taking the most lightest data set. It's called the aggregate 24 hours stats light. What you'll see is that I have taken the current epoch, right? So the aggregate, like I mentioned, it does that over a bunch of different base level snapshots, right? So while it is building, I'm trying to show you that this is definitely happening in the moment, and at that point of time it got completed, and this is the final aggregate snapshot that got computed, right? So this is me still giving you that data set which you see on top of that dashboard, right? And as you can imagine now, there are so many different data points of further subsets of the aggregation and also super aggregations that you see what comes as part of building out a dashboard, right? The last bit would be, how do you make a better dashboard, right? How about that? So let's kind of see that. This is so confusing. All right, yeah. So kind of coming back to that, how do you make a better dashboard out of all this information? You saw project IDs, you saw what an epoch is, you saw what is the final data set for that epoch, but how do you use it to make a quick, nice visualization like that, right? So I'm taking this one data stream called trade volume across that contract over there. Yeah, there. And I'm doing an API request which gives me back something called a finalized content identifier for that, right? So essentially what I do is, if I just let me move ahead a bit, this is a redundant part. Yeah. Okay. Yeah, this is me kind of showing you that that's the entire data set present within that trade volume snapshot for that epoch, right? If you see, there are a bunch of event logs that are captured with the event data, etc. Also, do check what I'm also checking, that I have a direct access to the data set itself. You do not need to even rely so much on Parloom protocol. You can go query it from any IPFS gateway. You get this entire data set. I hope you can start connecting the dots in your mind, how you can kind of drill down into these data sets, show very specific event logs, build nice graphs, build nice plots, things that kind of make for a much richer data experience, right? So they are things that we are definitely looking forward to for some hackers to kind of build on, start using all that data that we have, go deep into the deploy setup that we have for you. If you really want to know where these data sets are coming from, who is building out a consensus for this, you can use our ABIs that are already included over there. Interact with that. The RPC is already provided, how to interact with the Parloom chain, and you can even build a dashboard of what your fellow hackers are submitting for the Parliament protocol, right? So it's like a meta of a meta, if you could think of it that way, right? So things get really interesting with data if we kind of start looking really, really deep into it. How much meaning comes out of data is what you wish to do with it, and that's where we try to stay true to the principles of composability. That's what I have also tried to showcase over here. What an epoch is, how do you center all your calculations around it. I hope that kind of helps you get a quick overview. Other than that, of course, you have the docs and you have us if you have any questions, right? So, apart from that, I hope this gives you a quick insight into building some data rich applications that might help you going ahead, right? So cool. Thanks a lot for your time. Thanks a lot for your attention. I hope to see you on the booth and maybe on the Discord channels if you have further questions. Thanks. This is not coming.
It's, this side, yeah. No. Ah, there it loads. Yeah. Yeah, everything looks good. Hi, welcome to my workshop. I'm going to teach you how to build decentralized serverless applications with the graph. My name is Örjan Ausa. I'm working as an ecosystem manager for the Graph Foundation. If you have any questions after this workshop, feel free to come to our booth or go to thegraph.com/discord. We have a Discord channel that is dedicated to helping hackers, helping developers. So if you have any questions and we are not at the booth, if it's in the middle of the night, you can come there and we'll help you out. So first of all, I want to talk a little bit about why we need index data, because the blockchain is open, it's all public data, but it is optimized for writing data and not for reading it. You can look at it as a big public library where every day there's a new truckload of books coming in, and they're just getting added to the end of the shelves every day, and there's no ordering or sorting. And it's fine if you go into the library and you want to look at one specific book, you can find it, you know where it is. But if somebody asks you, what are the top 10 books with the most pages in each book, you would have to go into every single book, look at the page count, note it down, and then sort your table, and that would take a long time. Similarly, if we look at a more practical example, say you want to build a analytics dashboard. Some of you might recognize this. This is the analytics dashboard of Uniswap v3, and everything that you see on that page is coming from the graph. Looking at one of these, for example, if you want to see historic price action, knowing that the price changes every single time there's a transaction, if you wanted to get that chart over there from just querying the blockchain directly, you would have to make millions of ETH calls, find the price action of every single block, and then convert that into a table and into a chart. And if you wanted to do that on the front end, the front end would take literally hours or weeks or days to load, and that is not feasible. So that's why we have indexing. You need to pre-process that data. And in Web 2, you would do it by having your own server, and you would just update that. But there's a lot of inefficiencies to doing that. First of all, like running your own server would require a lot of expertise, it's a lot of cost, and it also is nowhere near as performant as we can get it with Web3 data. So let's dive into that. First of all, I touched on this a little bit earlier, like who needs index data? And that was a question we asked when we started close to how many years? 7, 8 years ago, since the inception of the graph. And it turns out that everybody needs it. We have over 84,000 subgraphs that have been created so far. So every single dApp needs to have some form of data in the front end. And with index data, you can do aggregation, you can do transformation of data before you show it on your front end. So that's where you get from just having everything in just a list, as in the Web 1 of data, to actually creating like useful user interfaces. In the Graph Network, we have served over 1 trillion queries so far. So that is what the Graph does. It gives you customized APIs tailored to your data requirements. And that includes rich, sorted, filtered, and aggregated data. And it allows for fully decentralized serverless applications. After all, if you're not fully decentralized, a dApp that is relying on one centralized server is just an app. If you're not fully decentralized, you're still having that one source of failure. So we currently support 45 different networks. On one of our products is the hosted service. It's a free centralized service run by one of the core developer teams at the Graph. And we are in the process of migrating more and more chains over to our fully decentralized network. We are currently at 7 chains, but more is coming every month. So we are currently expanding our multi-chain support, and there's quite a few networks that are currently in the pipeline. So, and again, why do we want the data layer to be fully decentralized? Well, first of all, there's no central point of failure, so there's no engineer that will call you at 5 a.m. in the morning and saying that your server went down, or your local government has put a ban on crypto, so you are no longer allowed to use your servers. it's innately load balanced and geo-distributed. The economics in the graph network does encourage indexes to serve data in like as much data as you need in that region. So innately in the economics of the graph network, if there's more need in a certain area, you will have more indexers serving that data in that area. We have censorship resistance. There's no, as I mentioned, there's no government that will take down your server because they are serving Web3 data. And most of all, and that is what most developers will focus on, is that with 300 indexes competing to deliver fresh and cheap data with low latency and high reliability, we know that the best performance you'll get by using a decentralized service or using the graph. So I'm going to give a quick primer of what a subgraph is. So a subgraph is one of our data technologies that we are using at the graph and that we have prizes for during this hackathon. And the subgraph consists of 3 parts that you'll be working on if you want to apply for any of our bounties for subgraph development. And that is the subgraph manifest. That's where you define what data you need from on-chain. So usually you would listen to events in smart contracts. So in the subgraph manifest, you will list the various contracts. We support also any proxy implementations or a factory style implementations that will automatically be indexing any implementation, contract implementation that the proxy is pointing to, or any of the contracts generated by the factory contract. So here you define the network, the contracts, start block that you want to start indexing from, and any events, calls. You can use also, you can have cron jobs running every X blocks. So all of that will be defined in the subgraph manifest. Then you'll define a subgraph schema where you'll define what entities you want to have stored in your GraphQL database. That's where you define, say you have a DeFi application, you might want to define like users and trades and various entities, and you can connect these entities. That is all done in the schema. So that would be the data structure, entities, relation between the entities. If you are going to build your own subgraph, I highly recommend that you spend some time on creating an intuitive schema that will save you a lot of time down the line. And then the meat of the code is in the subgraph mappings. That's where you take the data that you get from the events and the calls, and you map it over to entities in your schema. And it's in the mappings that you also do all the transformation of data or aggregation of data. So say you want to create a time series data, or you want to create any like counts, any other like aggregation of data, you would do that in the mappings. And if this sounds a little bit complicated, it's not that much to work that you need to work with. It's only these 3 files, and most of the things are happening in the schema and in the mappings. But you can also have the CLI create a scaffold code for you, and that allows you to create a subgraph and deploy it in less than 5 minutes. And from there, you can start working on more advanced entities and more advanced mapping code. So that would map all the events in your smart contract one-to-one to entities in your schema, and all of that is auto-generated. Usually, I would have a demo here, just showing how you can do it in 5 minutes. I wasn't sure if we were going to have an Ethernet cable and internet, so I'm jumping over that this time. But if you need any help with creating your subgraph, feel free to stop by our booth or reach out in Discord. We also have a Telegram channel for hackers. So yeah, feel free to reach out. We'll help you through it. And yeah, this is the prizes for our hackathon. So we have prizes for creating the best new subgraph. We also have the prizes for best use of subgraph. That could be your own, or it could be an existing one. And as I mentioned, there's already 84,000 subgraphs that are open and free for anyone to use. And you can find them at thegraph.com. We also have a technology called substreams that we are excited for anyone that wants to use. It's a different approach to retrieving data from the blockchain. It uses the Firehose technology to extract all of the data in a client into flat files, and then we use this Firehose uses Substream technology to extract data in a parallelizable way, and that allows for extremely fast extraction of data, which gives us a lot more use cases, or a lot of new use cases that subgraphs don't have. And if you want to take a look at that, we have a cheat sheet for substreams. We have information about the substream also in our booth, so please stop by, and we'll give you a primer on that as well. I also wanted to touch a little bit on how you can get more involved in the graph ecosystem and how the graph ecosystem looks. We currently have 6 core dev teams at the graph. So we have the Edgenode, who was the original founders of the graph network, and who are currently like building the core protocol and new tools and applications. We have Streaming Fast, who were working on high-performance data streaming. Semiotic, who's focusing on artificial intelligence and cryptography. We have the Guild, who is the leader of, or is one of the leading companies working on GraphQL in general, and they are working with the Graph on composition, analytics, mutations, and improving our GraphQL APIs. We have GraphOps, who working on protocol economics and the index experience. And we have Mesari, who develop standards and innovate on subgraphs. So they create, if you go to subgraphs.mesari.org, you will find a lot of standardized subgraphs across multiple like lending protocols, DeFi protocols. It's with the standardization, it allows you to analyze the data. So if there's any data analysts or data scientists here in the room, you will find a gold mine at their web page. They have standardized subgraphs for all the common DeFi platforms. So that will allow you to create some analytics cross platforms. And then we also have DAOs and communities in the graph. We'd be happy to also, if you want to get more involved, we have DAOs that are working on the advocate side, on grants, on communities. We have a builders DAO that is working on creating tooling, documentation, creating new subgraphs and substreams. And we also have InfraDAO that is working on R&D focused on the infrastructure providing side of the protocol. And we also have multiple other communities. So if you want to get involved in the graph ecosystem, there's a lot of different avenues. No matter what your skill set and background is, you're welcome to reach out, and we'll help you find a place in the graph ecosystem. Yeah, that is what I had for today, and I have the last 3 minutes is for questions. If anyone has any questions regarding building subgraphs, building substreams, the graph ecosystem. No questions? I don't see if anyone has a question. I don't know if there's any. Yeah. Well, that's all I had. So thank you for your time, and come by our booth, and happy hacking. Thank you.
Ethereum scalability bottlenecks. And what I really want to, my name is Patrick McCory, by the way, and I work at the Arbitrum Foundation. But we're not really going to talk about Arbitrum per se during this workshop. What I really want to do is give people here an appreciation for what does it mean to scale something like Ethereum. What are the scalability bottlenecks for Ethereum? And hopefully by the end of this workshop, you'll have an appreciation for why we should even care about rollups as a way to scale Ethereum. So it's a bit like a history talk, going back to basics, and hopefully picking up along the way how we sort of struggled to scale this network. So back to basics. How does something like the Ethereum network work? So as everyone's aware, we have a blockchain, block 1, block 2, block 3. And inside a block, we have a list of ordered transactions. And the fact that transactions are ordered is critical when you think about stuff like MEV, front running, back running, sandwiching. It's all enabled because we have a canonical history of all transactions, and all transactions have a single ordering. Now what about Alice? Alice is an inspector, and Alice wants to understand, or at least Alice wants to see what is her balance on Ethereum. And she wants to be convinced what her balance really is. So what she'll do is she'll join the network, download the blockchain, and execute the blocks in order. Block 1, block 2, block 3, up to the most recent block on the network. And by processing the blocks, what Alice should end up with is a copy of Ethereum's database. And then she can check her balance, and she can say, yep, I have 1 or 2 coins on the network. So if there's one takeaway from this workshop, if there's only one takeaway that you guys remember, the whole point of a blockchain is just to allow anyone to compute a copy of the database. It's a bit like a cryptographic audit trail. I execute the blocks in order, and I can get the same database as everyone else. And that's the only thing the blockchain really does. And then the second component is the peer-to-peer network. So Alice wants to send some coins. She's on her MetaMask, she puts in the transaction details, she signs the transaction, and then she'll want to get that out there and eventually confirmed on the network. The way this is achieved is using a peer-to-peer network or a gossip protocol. And the whole point of the peer-to-peer network is to broadcast recent blocks and recent transactions. And I believe today, Ethereum's peer-to-peer network has about 30,000 nodes. Maybe someone in the audience can double check that. But it's a pretty big damn-ass peer-to-peer network. It's pretty damn big. If there's 30,000 nodes facilitating this interaction. And of course, you can join the peer-to-peer network. You can download the blockchain. That's where you get a copy of the blockchain. And then, of course, compute a copy of the database yourself. Now, one of the big purposes of the blockchain is so Alice can send her transaction. It'll be sent across the network in a few seconds. And hopefully, a block proposer will pick up the transaction and confirm it and finalize that transaction. So when you think of the miners or the stakers, what these proposers in general are offering is a transaction ordering service. We trust the proposers to order transactions on our behalf. And generally speaking on Ethereum, they'll pick up the pending transactions ordered by fee and then confirm them based on whatever's going to pay them the most money. So they're trusted to do this. We trust proposers to confirm transactions. But thankfully, we don't really have to trust them because they have a financial incentive to do that. The more transactions they confirm, the more tips they pick up, the more money that they make. So again, the user sends a transaction to the peer-to-peer network, and then it'll eventually reach the block proposer. Now, what's important here is that the transactions are kept. So if you're running the node software, so you're running Go Ethereum or Aragon or Nethermind, every node client has a special piece of storage called the mempool, which is really just the pending transactions. They're not ordered, and they're just waiting to get confirmed in a block. It's really to prevent flood attacks on the network. So they're all, every block proposer has the same mempool roughly, and of course they'll produce a block. They'll produce a block that confirms these transactions. They'll send it to every single peer in the network. That takes about 1 or 2 seconds. And every single peer in the network will get the block, execute it, check that it's correct, and then they'll update their copy of the database. And so when you think about this process, all that's really happening is that the block proposers propose a block, send it to the network, and it's a bit like a batch update. every 12 seconds, there's a new block and there's a new batch update for your database. And that's basically, in a nutshell, how something like Ethereum works today. And what's really nice about this system is that because it does work, by the way, because hopefully we've all used it, I don't know. Raise your hand if you've used Ethereum before, let's check. Awesome, look at that. So everyone realizes this does work to an extent. What you get from this is a global bulletin board, a bit like this screen. Everyone in this room can have a copy of exactly the same database, so they have a consistent view of the state of the network, the smart contracts, the exchange rates, whatever. And what can you build with this? Well, you can build auctions, voting, tokens, transfers, gambling, NFTs and art speculation, trading, MMs. And that's all enabled because everyone in this room can have a consistent view of the same database. This single database is widely replicated. So where does scalability come in? If this is how the system works, what does it mean to scale this type of system? Well, we have to consider two actors. The first are the block proposers. And really, when we think about scalability, what are the minimum resource requirements needed to be a proposer on the network? In Ethereum, that is, what are the minimum hardware requirements or bandwidth requirements to join the proof of stake protocol? What's your minimum compute, bandwidth, and storage? And as part of this, as we're going to see, one of the parts of it is, can the block proposers propose the blocks on time so everyone gets a copy of it before the next block? But the flip side to it, which really makes cryptocurrency special, what are the minimum requirements to validate new blocks in real time? So everyone in this room, what are the minimum requirements for you to run a node, process blocks in real time, and compute the exact same database as everyone else? So what we really care about when we think about scalability is compute, bandwidth, and storage. Keeping in mind, how do we decentralize both of these actors so we can maximize who can participate in the network? So scalability cares about resources and that right balance between proposers and verifiers. It has absolutely nothing to do with transactions per second. So if you leave this workshop and you say, oh, Paddy was telling me that TPS is the source of scalability, you never took this workshop, guys. Nothing to do with TPS. TPS is like a proxy of this problem. So back to basics. We spoke about the block proposers. They offer an ordering service to the network. We spoke about verifiers. Anyone in this room can download the blockchain, process blocks, and check that everything's correct. There's a peer-to-peer network, and we spoke about scalability. So what are the scalability problems faced today? And my goal here is to give you a taste of those problems. So first, we're going to start with bandwidth as the resource. How long does it take for a transaction to get across the network? And in this case, we're going to assume the entire system's honest. All the block proposers are honest. Everyone in this room's honest. The peer-to-peer network's honest. There's no malicious behavior. It's the ideal, it's the best case setup. So when we think about bandwidth, what we are really talking about is the fork rate. And raise your hand if you've heard of the fork rate before. Awesome. A few people. Great. That's a perfect audience then. So what do I mean by the fork rate? So let's say there's two blocks created at the same time. Block proposer A created block 3A, and block proposer B created block 3B. The issue here is that we have two competing blocks, and they're both valid blocks, but only one block can get in the blockchain. So let's just say I created a transaction, and I sent Alice 1 ETH, and that gets confirmed in block 3B. Okay, so Alice is going to get 1 ETH as long as block 3B remains in the blockchain. The issue that arises is what if 3B gets discarded? Block 3A gets minted, then block 4, then block 5. So the top part becomes the canonical chain. Block 3B, it's not part of the chain, it gets discarded. So in this case, out of 6 blocks, we have a 16% fork rate. And what that really means is that the network's not reliable in the short term. I can get a transaction confirmed, unconfirmed, reconfirmed, and then maybe discarded. And that sucks from a user experience. If your transaction gets a confirmation, then that should hopefully lead to more confirmations, and you shouldn't be in this state of limbo where it's sort of going to get confirmed, then it doesn't get confirmed, then it gets dropped, then it gets back in. That doesn't help the user. So that's what the fork rate's about. How do we minimize competing blocks so there's only one canonical chain that's always being built? And again, as I mentioned, why do we consider this? Because if the blockchain's tip's unstable, it's just bad for the user because the network's not reliably confirming transactions. And as part of this, when you think about the fork rate, there's two components to it. One, how long does it take for a block, what is the length of time it takes for a block to reach the entire network? So if I produce a block, how long does it take for everyone in this room to get a copy of that block? And the second component is frequency. How often are blocks created and produced? So let's use some simple examples. Big versus small blocks, if you remember the block size wars. So let's consider a small block world. There's a 1 megabyte block every 10 minutes. So in this scenario, it's 1 megabyte, it's really small, it's going to zap across the network really fast. Within, maybe 5-6 seconds, everyone in this room can get a copy of that block, you will have processed it, and you would have updated your database. And if there's a block every 10 minutes, then there's a very low probability that a competing block was created by the time your block was getting across the network. So there should be very few forks, intuitively. The flip side to that is, what if there's a 1 gigabyte block every 30 seconds? If it's a 1 gigabyte block, then it's probably going to take me a minute to get it to everyone in this room, so everyone gets a copy of my block. So as the block's going across the network, maybe someone over there in the front row, you're a block proposer, you create a competing block. You didn't get my block in time, you're still working on the old block, so then you create your block, then you broadcast that out. And then you have 2 gigabit, you have 2 blocks going out and trying to get across the network. And then maybe, of course, there's a third block, and obviously this isn't working. This sucks for everyone involved because, one, the network is unstable, and 2, you're just wasting bandwidth. There's only one of these blocks get confirmed at the end. So the question is, can you get really good numbers on this? And for the sake of time, actually, not for the sake of time, I got it here. So to put some good numbers on this, and this is about a year old now, I think the slide is. In Ethereum, blocks are about 120 kilobytes, and they're every 12 seconds. And on Bitcoin, they're 1.2 megabytes, and they're every 10 minutes. So in proof of work Ethereum, before the merge, there was a fork rate of about 5 to 6%. And that clearly sucks for the users involved. With proof of stake Ethereum, it's less than 1% now. And that's really because proof of stake Ethereum is more synchronous. There's strict deadlines to do stuff. So people know when to create a block, when to validate a block. It's a much more structured system. Where on Bitcoin, there's a fork every 1 to 2 months. They're so uncommon that BitMEX writes a blog post when there's a fork. Because it's a big event in Bitcoin that there was one fork and one stale block. So what's the ideal block size and interval? That's always a moving target based on the composition of the peer-to-peer network. So there's a research paper called On Scaling Decentralized Blockchains. It's from 2016. I think at the time it recommended a 4 megabyte block every 1 minute. But back then that was like, God, that's like 8 years ago now. The network's way more effective than it was back then. But when you're thinking of this question, this trade-off, the ideal block size and interval, the question's really, what percentage of the world's population could download that block, process that block, and pass it on while keeping up with the network? If I can only process a block every 10 seconds, but there's a block every second, then I just fall behind. I get the block, I process it, I pass it out. Oh no, now there's 10 blocks. And then I just can't keep up with the network. I can't keep up with the latest state. So it's just not useful for me. I'm always behind. So you have to really consider, if someone's in Africa, Australia, US, Hong Kong, whatever, you have to consider, 90% of the population, based on the peer-to-peer network today, what are the realistic settings that you could put so they can actually get the blocks in real time? So that's bandwidth, fork rate. Hopefully that gives you a sense of the bandwidth problem. The next one is hardware and compute. And really the question is, how long does it take to compute a fresh copy of the database from scratch? So if you download Go Ethereum today or a Bitcoin Core, how long does it take you from scratch to get up to date with the network? And James Mlop does an experiment every year testing exactly this problem. And I'm sure he'll do one in a few months. It's normally around the new year. So look out for this blog post. He has a relatively beefy machine, 1 terabyte storage, 6, I guess, Core i7, some CPU. Regardless, let's look at the results. So in 2021, he was able to sync a Bitcoin full node from 2009 till today, every single block in about 400 minutes. That's pretty damn fast to process 14 years worth of transactions. On Ethereum, his Go Ethereum node ran out of disk space, so he wasn't actually able to complete the task. And this was after 5 days and 21 hours, and then he, based on the work, he suspects it would take 10 days to sync Go Ethereum. Again, this is 2021, 2 years ago. But the most interesting part of this is at the time of the crash, Go Ethereum had 15 terabytes reading from disk and 12 terabytes writing to disk. And as you're going to see, the database isn't that big. The database is like 600 gigabytes. So why is there so many I/O operations? Seems a bit much. And actually what he worked out was executing transactions is not the bottleneck, is I/O, reading and writing to the database itself. That's the bottleneck in Ethereum today. So then if you look at Aragon, because he ran Aragon, because he really does just want to synchronize a node, with Aragon he was able to finish it, and interestingly Aragon's I/O was much better. It went down to 1.9 terabytes and 1.8 terabytes. So the question is, why would it take 10 days to sync Go Ethereum, but only 2 days and 16 hours to sync Aragon with a lot less I/O? The reason is because of this tweet. And let me give you some detail. So in a block header, we have something called the state root. The point of the state root is that it's a single hash that represents a commitment to the entire database at this point. So you can consider the database, you build a Merkle tree or Patricia tree, you end up with a single hash, and you put it in the block header. The reason why you have this is because if I want to prove what your balance was at a certain block, I can use the state root to prove an entry in the database. So I can prove to you what your balance is, or what the size of an LP pool. I can prove to you information about a block at a certain time. So that's why it exists. But Aragon stopped checking that. It just skipped that check altogether, and I was like, whoops, not going to check the state root, it's too expensive. So what they would do is you would synchronize from the Genesis block up to the latest block. Then if I remember correctly, they would randomly sample previous state roots. And with the random sampling, they would get some guarantee to say, well, there's probably all the state roots are correct if you only check a subset of them. But that's interesting. To get over the I/O issue, you have to stop fully validating blocks. So the surprising takeaway here is really executing smart contracts in memory. It is expensive, but I/O is actually the real bottleneck. And other blockchains, this is again just from his tweets. In ETHIndia, they just gave up on the issue. You had to buy your hardware from an approved supplier to run a node. And even in Solana, again, this is 2021, they have these crazy requirements that most people aren't going to have at home, like 128 gigabyte RAM. I don't know what it is today. That's from 2021. But it's just, and this also isn't a wrong choice. It's just a design choice on how many people in this room could validate the blockchain in real time. That's really the decision here. And obviously there's a spectrum. So that's compute. Hopefully that gives you a taste and a flavor on the computational problem. But what about storage? So when we think of storage, there's 3 different things that we store. One is the database, the mempool, those pending transactions, and then the blockchain itself. And the question is, what's the minimum data required to run a node and validate new blocks in real time? So a copy of the database, and I think this is from 2022, the Bitcoin database is really small. It's about 5 gigabytes. It's not that large. Where when I checked Ethereum, a normal node, a full node, which we can talk about later, it was about 700 gigabytes. It's probably a bit bigger now. And then an archival node was you'd only run if you're an explorer, because it's really making it easy to look up historical data. It's 10 terabytes for Go Ethereum back then, or about 2 terabytes for Aragon. But the problem with the database is that the database never gets smaller. And I'll illustrate this with a question. How many people, who in the audience writes smart contracts? Raise your hand if you write smart contracts. Okay, raise your hand if you delete data in your smart contract. No one, no hands, look at this. Great citizens of the world. And that's important, because the database never gets smaller because no one deletes data. So this database is always growing. If I remember right, this is like 2 years ago, I think on Polygon, and this was an archival node, so, pin to self there, but I think their database was growing, or their storage requirements were growing, 1 megabyte every 2 seconds. That doesn't sound like a lot, but eventually it gets to 15 terabytes, and it doesn't fit on AWS anymore, and it never gets smaller. So that's one of the big bottlenecks on Ethereum. A copy of the blockchain for Bitcoin is actually quite big. It was about 400 gigabytes at the time, and that's just because Bitcoin transactions are bigger because of the UTXO model than Ethereum. And on Ethereum, it's about less than 200 gigabytes when I had this screenshot. I think that was a year ago. It's probably not that much bigger now. Maybe someone in the audience wants to check if you have Go Ethereum installed. And then finally, the mempool. The mempool's, that's like back of the envelope. It's about 100 megabytes. It's not really a bottleneck when it comes to scalability. And it's really just to stop flooding of the network. If I hear a transaction once, I don't really want to send it again. So that's, to give you a flavor of the resource requirements. We looked at bandwidth, compute, storage, and we're really just understanding, okay, these are the problems on Ethereum today when it comes to scalability. So pop quiz. I actually forgot I had this here. Why do we have the gas price and a gas limit on Ethereum? The reason why we have it is because we need to prioritize access to block space. Block space is our most scarce resource. So if there's high demand and high congestion, the gas price goes up, and only the people willing to pay the most money can get access to the block space. But the reason for the gas limit is really to limit the maximum growth of the database and basically compute on the network. If the gas limit is 30 million gas over a period of a year, we can have a rough estimation to say maybe the database will grow 20 gigabytes this year. Where if the gas limit was bigger, then of course the database would also get bigger because it's just cheaper to transact. So the gas limit's really there to prevent the growth of the database, and then compute is like the second priority after that. So again, a bit of a summary. We looked at storage, compute, bandwidth, and the problem is if you just blow up the transaction throughput, you want to support 1,000 transactions per second, the blockchain just becomes unstable. It leads to more forks, it's bad for the users, and then people in this room, you won't be able to keep up because there's too many transactions, database gets too big. Like Jameson, couldn't run Go Ethereum, doesn't help. So to the final part is fighting back. How can we scale something like Ethereum while trying to adhere to the principles of being decentralized, i.e. maximizing who can participate as a proposer or as a verifier running a node at home, so you can just have a copy of the database yourself. So scalability has 2 goals. 1, reduce the fork rate. Fork rate should be highly reliable for everyone involved. And 2, maximizing the population of nodes. So everyone in this room can run a node and verify that the database is correct and have access to the database for whatever dApp you're building. And there's lots of widgetry tricks we can do to bring this down. Lots of widgetry tricks from engineering. You can compress data over the wire. Maybe you have a private relay network. Bitcoin had that for a very long time, where you bypass a peer-to-peer network completely and the blocks are sent directly to the miners. Maybe a parallel execution. If transaction 1 and transaction 2, they don't interfere with each other, why not run them at the same time? So they're parallel and you're not just running everything sequentially. Or maybe you make better use of the bandwidth using special cryptography tricks. So this is needed, and this should be implemented. So basically, given your set of resources, you're making the most efficient use of those resources by doing this. So you don't increase, the storage or the bandwidth or the compute, but you're making better use of the resources that you have. But it only goes so far. There's only so many widgetry tricks you can do at that level. as we saw with the block size wars and over the past couple of years. So is there another way? Is there another way to solve this problem? And the way we like to think about it in the L2 world is, can we protect the peer-to-peer network? Can we protect decentralization of the peer-to-peer network such that the peer-to-peer network can check the results, but you move all of the hard work out of the network? So Ethereum is no longer storing the database. Ethereum is no longer computing all the transactions. Ethereum is just checking the result of what happens somewhere else. So all the hard work happens over here. You can have different resource requirements over there. But on Ethereum, we just check the results. We don't actually do the hard work ourselves. Can we do that? And this is sort of the play on, the monolithic architecture versus the microservices or the modular, sort of narrative or theme. Right now, Ethereum is trying to do all the work itself. Can you move the work elsewhere? And what this has sort of led to is renaming the resources the special layers. So compute is now the execution layer. Bandwidth is now the data availability layer. Can I guarantee the broadcast of data and it reaches everyone in this room at a certain time? That's now the DA layer, but it's really just bandwidth. And then 3, storage, the settlement layer. Where is the database that records all the assets, and it is the source of truth itself? And it may look like a simple renaming, but by renaming these resources to layers, we can solve each problem individually and, of course, hopefully scale the network. And so for the final part, because we only have a few minutes left, off-chain in the multi-chain world. So the way this works for the roadmap, the roll-up-centric roadmap is you take your coins, you lock it into a bridge, then you unlock it on an off-chain system, you transact there, and then you bring the coins back to Ethereum. So what is the off-chain system? So let me ask the audience. Who's ever used an exchange before? Who's used Binance, Coinbase, Bitstamp? There you go. We found the people who bought the shit coins. I'm only joking. But what's important is that this is how we've actually scaled the network for the past 14 years. You take your coins on Ethereum, you put it in this bridge, then it pops up on Coinbase, Kraken, Binance. You perform all your transactions there, then you bring your funds back. So this is actually how we've already scaled. Bitcoin and Ethereum in the early days were an interruptibility solution for the exchanges. You buy your coins in Coinbase, you move it to Binance, you mess about with the shit coins, then you move your funds back. And people aren't actually using the cryptocurrency, they're using the exchanges. But the problem with exchanges is, one, most people here are aware now, they're fully custodial, they can freeze our funds, they can confiscate our funds. Maybe they'll use our funds to buy some villas in the Bahamas. They can lose our funds. They're not auditable. I can't check if they're solvent. I can't even check if they've been audited. There's no way they audit the system to make sure that every transaction process there was actually correct. We just have to trust the operator to do that. And that sucks. So could you have the off-chain system to be a blockchain? Where I take my coins, I bridge it over, it's another blockchain, I transact there, and because it's a blockchain-based system, I can verify the blocks, I can download the blocks, I can execute them, and I can check that everything's correct. And then eventually I bring my funds back to Ethereum. And what's nice here is that if you can do this, Ethereum becomes a settlement layer, and all the hard work happens on this other blockchain system. And with the bridge, you can then check your assets against the liabilities. The assets are on Ethereum, liabilities on this off-chain system. You can check that they're correct. You can have full-time audits, or real-time audits. It's just a much better tech stack for building these type of off-chain systems. And that's what we're trying to build with rollups. When you think about rollups, they're really just replacing these custodial services. The Arbitrum, Starkwares, Optimism, ZK Sync, Scrolls. It should eventually feel like you're interacting on an off-chain system, but in a way where you don't have to trust the operator. And that's my final slide, so thank you guys for listening. Whew. GG? Oh, I need to unplug this. Awesome.
How do I plug this in?
You can connect.
Thank you. नहीं थैंक यू
HDMI कनेक्ट हुआ है क्या?
HDMI
HDMI भी नहीं आया भाई, USB पोर्ट ओनली, उसका कन्वर्टर होगा.
You don't have an HDMI?
No, only USB ports.
we could have right.
Only C type.
HDMI converter.
Yeah, we had right.
Thank you. How do I connect this LAN thing?
Okay, you have only one C port?
No, I have two.
Yeah, I get it.
But what about the Wi-Fi? How do I?
Wi-Fi, no, it's connected to the Ethernet.
Yeah,
LAN,
no,
na?
but it's not working.
It's an
I have to
automatic.
enter a login. I have to enter this code, right?
No, it's
this
LAN,
is
right?
Direct. This is direct.
Yeah, but I have a LAN code.
No, this is direct.
Okay.
It's a direct. So maybe you have to change the settings. Can you just check that?
Yeah.
Meanwhile, we
We
can
just
sort this
switch
out.
off the Wi-Fi and just try it and get LAN connection.
Okay,
Is
yeah.
it discoverable?
Perfect.
Yeah, it's okay.
Yeah. Converter?
I give it. You have it. That's okay.
Cool.
The timer is there. So you just have to check that. Okay. Hold on. Yeah, it's done. It's there.
However you want it. Okay.
Yes. Hello, hello. Sound check 1, 2, 3. Works fine? Cool. Ready? Good. Okay, all right. Hey everyone. So my name is Mizan. I am a mobile engineer at Huddle 01, and I'm going to conduct this quick workshop where I'm going to be showing you all how you can add real-time audio-video communication to your React applications. So I chose this because most of the hackers over here use React for their hackathon projects. So how many of you are using React to build your projects in this hackathon? Okay, nice. That's nice. That's a quite a good number. So if you want to use audio video in your application, you can use our SDK to do that. And we also have multiple track prizes, which I'll announce at the end of my talk. You can apply for those bounties as well. So to get started, let me talk more about what Huddle 01 does. So we follow something known as a three-pronged approach. The first one is our Huddle 01 app. So it's a video conferencing platform just like Zoom or Google Meet. And we also have a mobile app and a web app for the same. The second layer is our SDKs and APIs, and this is what you are going to be using in this hackathon. So these SDKs allow you to integrate audio video in your applications in as less as 10 lines of code. That's all you need. And fun fact, we also built our web app and mobile app using these same SDKs. So they're available for you to use in this hackathon, so feel free to use them. That's what I'm going to be talking about. And the last layer is our DRTC protocol that we are working on. So what this allows us is to create a people-powered network. Our protocol engineer is on our booth, on the Huddle 01 booth. You can come and talk more with him about this protocol. So what you want to focus on in this hackathon is the SDKs, and that's what I'm going to show you all. So quickly, this is what our apps look like. On the left, you see the video call layout, and on the right-hand side, you see the audio spaces. And you could do all of this in your own app using our SDKs. So we have the multiple solutions that our SDKs provide are plug and play APIs and recording. You can also record your calls in your own application, and you can also bring your own Web3 identity. So that means you can use NFT avatars and your decentralized names inside the meeting using our SDK. And we also have token gating. So this allows you to create locked rooms, which can only be joined if you have specific tokens in your crypto wallet. And this obviously is done using the crypto wallet login. We offer multiple login options as well. And the last thing is the customizable iframe. So we also have an iframe offering which allows you to embed video calls without much customizability. But sadly, that's not what you're going to be using this hackathon for the bounties. You have to use the SDKs, not the iframes. So that's another solution that we offer. So the three SDKs that we have are React.js, React Native, and Vanilla.js. We have Flutter and Unity SDKs coming soon, but these three are available to use right now. So let's get started. I'll quickly show you a React app and a very simple video calling app, how you can how you can join a room and have multiple peers join the same call. So to do that, you need to install two packages. One of the first one is the Huddle01/React package, and the second one is the Huddle01/Server SDK package. Now the important thing is that we recently launched our alpha versions of these SDKs, and that is what you want to be using for this hackathon. So your submissions will only be accepted if you're using the alpha SDKs. So to do that, when you install using npm or yarn, you just need to add @alpha at the end of the package name, as you can see on the screen. So the Huddle01/React package is the client-side package. It allows you to do all the important things such as joining a room and also sharing and receiving video and audio streams. And the second package, Server SDK, is a utility package which allows you to log in and get access tokens for joining the rooms. So that's a very small package, and you'll use it only in the beginning. But most of the heavy lifting will be done using the React package. So be sure to use the @alpha while installing the packages. So I have a demo app over here, and if I go to my package.json, it's a quite simple Next.js application. And if you see in the dependencies, I have the React and Server SDK installed, which are the alpha versions of the same. So once you have installed the application, the first thing you need to do is wrap your app inside a provider. So this is what will initialize your application. And so at the top level in your app.js file, you need to import the Huddle provider from our package. As you can see at the top, those are the import statements. And I hope it's visible. So yeah, we expose a Huddle client, which you can initialize like this, and then you wrap your app inside the Huddle provider, as you can see at the bottom. So to do this, you need to pass two options over here. The first one is the project ID. The project ID is the compulsory param, and the second one is an options parameter, which is optional. So for the project ID, you need to go to our documentation, which is alpha.docs.huddle01.com. So please make a note of all of this. And once you go to the documentation website, you'll see the get an API key section over here at the bottom. Once you go there, you have to connect your crypto wallet. I'm going to be using MetaMask. And once I connect my wallet, two secrets will be generated for me here. The first one is the API key, and the second is the project ID. I'll show you where you're going to be using both of them. But like I showed you earlier, the project ID, this one, the one at the bottom, is what you're going to be using over here. So when you initialize the app using the Huddle provider, you need to pass this project ID, and this project ID is unique and secret to your own project. So put it in your env file and do not commit it to GitHub, and like protect it in that manner. So once you've done that, your Huddle client is initialized, and you can like join rooms and get started with the audio video communication. So once you do that, the next thing you need to do is create an access token. Now, like I mentioned earlier, you have an API key also generated over here, and this is what you're going to be using to get your access token. So like I mentioned earlier, the Server SDK package allows you to create an access token, and this is done on the server side. So if you're using Next.js, you can put this in an API route, or you can put it inside your server-side rendering route, like get server-side props. Or if you have a dedicated node server, you can do this over there as well. So I'll show you how I have done it in this sample app. In the sample app, I'm using server-side rendering. So over here in my Next.js index route, I have this get server-side props function over here, and I'm initializing my access token over here. Now this access token is unique to every participant in a room, and it allows you to join only one single room. So you need to pass these two parameters over here. API key is the one that I showed you earlier that is generated for you, and the room ID. Now for the room ID, you have to use something called the create room API. So if you go back to our documentation and you go to API reference, you'll see a create room API over here. So this can also be done from the server side as well as from the client side, or you can also use Postman if you want a hard-coded room ID for all of your rooms. So once you call this API route, you'll get a room ID. So now you have an API key as well as a room ID, and that's what you need to pass over here while getting your access token. Now this is done for every single peer, and once you do that, these are some additional parameters that you have to pass. All of this is the default, this is what the default options look like. So you can take a picture of this as well if you want, or you can make a note of it. But all of these are like detailed advanced stuff. So if you want to know more about what happens when you change these parameters, you can like visit me at the booth, and I'll walk you through all of that. But to get started, this is all you need. These are the default parameters. All of them are set to true, as you can see over here. And you can also pass a wallet address over here. So if you're using crypto login in your application already, you can communicate with that layer and get the wallet address of the user and pass it over here to get that specific access token. Now, once you've done that, this token, I'm sending it to my client side using server-side rendering, and I'll get it over here at the top of my Next.js page. So I'm getting the token over here. Now that's done as well. So now I have initialized my app, and I also have an access token. That's all you need. Now we can get to the good stuff. So the next step would be obviously to join a room where you can chat and like video call with other participants. So all of our functions inside the React SDK are available through hooks. So for joining and leaving the room, there's a hook called use room, as you can see on the screen. And this use room exposes two functions to you: join room and leave room. It's that simple. And when you call these functions, you'll obviously be able to join or leave a room. So if I go back to my demo app, I have this hook called over here. It's use room, and it returns to me join room and state. And if I did that, it would give me a leave room function as well. I'm not using that function in this app, so I don't need to import it. But if you were doing that, you could get it over here. And this join room is a function that is callable. So once I've got that, I can scroll to the bottom, and I've created a button over here which says join room. And on click, I've added the join room function that I'm getting from the hook. Now this function also accepts two parameters. It's like one parameter, an object, and it takes two fields, the room ID and the token. So token is obviously the one that we got from the server side, the access token. And the room ID is the same room ID that you use to generate the access token. So if I entered another room ID over here, you wouldn't be able to join that. So that's how we ensure security and privacy. So for every peer, there's a unique access token, and that token is unique to the room that was used as well. So this is what it looks like if I go to my app. I have these buttons over here that I've added. The first button is the join room button, which I just showed you. And when you call the join room function, you'll be able to join the room. So we'll quickly do that. So over here at the top, you can see something called idle. So that is the state returned from the use room hook as well. So the use room hook also returns something called the state, which is the state of the room. It can be either idle, connecting, or connected. So once I click on the button, you'll be able to see that it changes to connecting for a brief moment and then to connected. So once I click the button, it changed from connecting and then to connected, which means that I've successfully joined the room, and now I can share and receive audio video streams from other participants. So once I've done the join room thing, we'll move on to the next hook. So once the join room is done, we need to check out the video audio hooks, right? So in this application, I'm just going to show you how you can fetch your own video and share it with other participants. So the next hook is something called use local video. Now, use local video, as the name suggests, relates to your own video streams. So local stands for your own video streams, and it gives you it returns multiple items here as well, just like the use room hook. So the important functions over here are enable video and disable video. So these are the two functions that you're going to be using to turn on your video inside a meeting room and turn it off. So again, I've added a button at the bottom for both of those. So I've added a button that says enable video and a button that says disable video, and I'm calling the respective functions when I click those buttons. So once I click on enable video over here, you'll be able to see that that's me, that's my video, and that's my local video. I can also click on disable video to turn it off, and it's gone. So that's how you would use the enable and disable video functions. Now those were for your own video, right? For a local video. But what if there are multiple participants in a call and you want video audio streams coming from those as well? So we'll move on to the next hook for that. The next hook is called use peer IDs. Now what use peer IDs does is it returns only one thing, which is an array of the peer IDs. Now these peer IDs are unique identifiers for every participant in a room. So what this will allow me to do is it will give me a list of all of the other participants excluding myself. So once I get those participants, what I can do is I can map over them, and once I've mapped over them, I can render a video component for all of them. So that's what I've done over here. Peer ID, it's a string, And once I map over it, I'm rendering this component of mine called remote peer, and I'm passing the peer ID to that component. So this is what the component looks like. It's nothing, it just renders a video component. And I'm doing this for every peer ID in the meeting. So inside the remote peer, I've got the peer ID and I know that these are the participants inside the room. Now, how do I fetch their video? So like I use local video for my own video streams. Very similarly, there's something called use remote video. So you can see all of this symmetrical nature between the two hooks. So local stands for my own video and audio streams. Remote stands for other participants. So once I'm rendering this video component for all of the participants, I'm calling the use remote video hook, and I'm passing that specific peer ID to that hook. Once I do that, it will again return me a stream, which is the video stream coming from the other participants. And once I get that, I'm just rendering it inside a video tag, a simple HTML video tag. And yeah, that should be it. So once I go back to my app, I am enabling my video again. And this time I'm also opening the same server in another tab. And you can see over here also the room is in idle state right now. So I'm joining the room from this tab as well. And once I do that, I can see the video stream coming from the previous tab. Again, the room state says connected, which means I'm in the room. And now I can enable my video in this tab as well. And that's me again. I can disable it over here as well and enable it back. Now, if I go back to the previous tab, it's the same. You can see the one at the top is my own stream, and the one at the bottom is the remote stream coming from the other participant. And similarly, if I opened another tab and joined as a third participant, I would do the same. I would join the room and be able to see the other two participants, and I could enable my video over here as well. And it would just keep adding all of the peer IDs in the similar fashion. So this is how simple it is to use our SDK. The important hooks that you need to know are use room, use local video, use remote video. And similarly, if you wanted audio, it's the same. Use local audio, use remote audio. So that's all you have to do. You have to use these hooks to build our application. I'm going to be at my booth, and if you want, you can come and chat more about your project. And if you need any sort of help, I'll be there to help you throughout the hackathon. And yeah, we have 3 different tracks we have started, which we're going to be distributing, I believe, at the exit of this room, or maybe somewhere, or you can even get it at our booth. We also have merch for you all, t-shirts and everything for grabs, so come and take those as well. And yeah, these are our documentation. So please scan this. This is very important. You need to use the Alpha SDK and the Alpha documentation, which you can get by scanning this QR code. So quickly take a picture. Done. I see someone over there. Okay, all right. So this QR code is also available at our booth on a poster. You can come there and scan this as well. It takes you to alpha.docs.huddleopen.com, which is at the bottom as well. So yeah, these are some example apps that we have. If you want to see how you can implement it. So the GitHub repo links are also at the bottom over here. You can take a picture of this as well. This is just a reference app for you, so you can take a look and build your own app similarly. The first one is a collaborative whiteboard, which is like a real-time multiplayer whiteboard like Figma. And we also have an audio spaces app, which is like a clone of Twitter Spaces built using our own SDK. So the GitHub link is at the bottom and the live URL is at the top. So you can make a note of that as well. And these are our socials. The first one is our Twitter. Do tag us when you're building your projects, and we will give you exclusive merch for that as well. We have a lot of items in store for you. And the second one is our Discord server. So all of our development team, marketing team, everyone from the Huddle Open team is actively available on Discord if you need any questions or any help and you cannot find us. So drop a message on our Discord server and we'll be happy to help you. I see a couple people taking pictures of this as well. All right. So if you have any questions, I'll be happy to answer them. And yeah, thank you so much. We're giving away t-shirts. My team members are giving away t-shirts, stickers, and a lot of different swags. So please collect them once you're done. Thank you.
Check 1 2. Hello. Check 1 2 2.